Pablo Benjumeda, as Noelia said. I'm Chief Operation Officer and co-founder of Orbital EOS. The name of this presentation is From Pixels to Solutions, because I want to put the focus in the way we work of extracting information from such amount of data that we have in space, so that we are a company specialized in data analytics, and our mission is to provide insights from this data. We are a Spanish startup. We are based in Valencia, and we provide maritime solutions. Why maritime? Why we are focused on the maritime domain? Okay, let me explain a little bit the story of Orbital EOS so that you can understand why we do what we do. As every story, we start from the. Oh, now it's okay. We have the luck to work, both Juan Peña and I, which we are the co-founders of Orbital EOS, to work for the Spanish Coast Guard for 12 years. The Spanish Coast Guard is a society, is what we call in Spain Salvamento Marítimo, and it has the mandate to provide search and rescue, pollution monitoring, and vessel traffic monitoring as well in the Spanish economic exclusive zone at sea. So there are many assets for the Spanish Coast Guard, and there are many vessels, helicopters, and aircraft. Okay, so this aircraft was my office for 12 years. I was working inside one of these aircraft, and apart from being an asset for search and rescue purposes, we work a lot for pollution monitoring. So this is me in the aircraft. Behind me is Juan, the CEO, and the other co-founder of Orbital EOS. So we was working as tactical coordinators in this aircraft. Our mission was to coordinate pilots, maritime rescue coordination centers, vessels, and other aerial assets for search and rescue, and as I said to you, pollution monitoring. We were managing remote sensing equipment in the aircraft, and we could deliver these missions during the day, during the night, even through the clouds. It's great, the use of remote sensing equipment in this situation on board the aircraft. And dealing with pollution monitoring, we understood one thing that maybe you are surprised, is that about 2 million tons of oil end up at sea each year. And what is most important, most of that goes undetected. This is very overwhelming. Once you are dealing with pollution and you detect 100 or even 1,000 of spills, as we have seen with our naked eyes, it's impressive. You will be more impressed if you know that only the 10% of the oil reaching the sea each year comes from accidents like the Prestige one that we're all here in Spain we are very aware of, but some other accidents like the recent one in Mauritius Island, or even the Deepwater Horizon explosion in the Gulf of Mexico in 2010. Or there are some menace. There are something very, very threatening in the Red Sea. If you have seen, if FSO Safer is a vessel with 400,000 tons of oil inside that is about to explode in the south of Red Sea. All of this oil coming to the sea from accident is only the 10%. What about the rest? The rest comes from natural leaks and illegal discharges from navigating vessels and from oil rigs. This is due to not the best practices when managing the waste, but in the end, it's a very threatening pollution, and it's something to take into account. Mostly, if we consider that there are about 95,000 ships at sea and 1,400 oil rigs, it's something that we should consider not to forget. But the problem is that oceans are really, really big. It's about 2.5 the size of the continents, and it's a very difficult area to monitor. It's very, very, very difficult to have a global understanding of oil pollution, and we are really, really sure that satellites can help us in this task. That's why we started to research. We started to think about. Once we were working with the Spanish Coast Guard, but now we are using satellites. Well, with this purpose, we try not only to collect the data. We need to know if there is oil, but we need to know much more different things. For example, it is really oil what we have detected, because sometimes there is something similar to oil, but we really don't know if it's oil. We need to know the quantity. If we can estimate the volume, it's very important. We need to know who is the polluter, who is the culprit. Mostly for authorities, it's very important to know who is the polluter. And we need to know, once there is an oil spill, where this spill will go. And we are absolutely sure that this information can be achieved with satellites. So now we are flying higher. We left the aircraft and we are now flying from 1,000 feet. We were flying with aircraft. Now we fly to 800 kilometers. So why we did the step? Because we firmly believe that satellites can see the big picture. I mean, when we were flying with the aircraft, it's great. We have a very nice capacity of monitoring, but we could see with the sensors even about 15, 20 kilometers of area each side of the aircraft. Now with these new satellites, for example, the one from Copernicus, we can see only in one pass about 270 kilometers. Is a sensible difference. Another very good thing about satellites is that they don't rest. Satellites are monitoring all the day and all the night. This is something that we cannot do with aircraft, because air crew have the necessity to rest. And the third thing that we think that satellites are very, very important is that they transcend all human boundaries. Why do I say this? Because many times we saw some kind of pollution, but we couldn't go to analyze and to extract data from that, because it was only a few kilometers above the Spanish boundary, so that there is no possibility for a Spanish aircraft to fly there, so that this pollution is not that do not count. So it's important for satellites because they see all over the planet every day, every night. This is the most important. So in this case, we use satellites with different technology. Here we see Sentinel-1 from Copernicus, Sentinel-2 from Copernicus as well. One is radar and the other is optical. In orbital EOS, we realized that the use of optical sensors for pollution monitoring was important. Traditionally, for oil spill detection, there is only a use of SAR sensors. Maybe it's because all this technology was developed in the north of Europe, and of course there is a lot of clouds, and they thought, okay, maybe with optical sensor we cannot provide nice information. But using optical sensor, once you are flying in the Mediterranean, you realize that, okay, there are about 75% of the days during 1 year are cloud-free. So 70% of the imagery taken from Sentinel-2 is available. So we can double the monitoring capacity. And no one is using optical sensor for pollution monitoring. This is what we realized. So we started to research and to extract information about the spectrum and the behavior of the oil spills from optical sensors. And of course, we use radar as well. But the combination of both is what we find really, really interesting. This is a radar imagery and optical imagery. The radar is great. We can see during the day, during the night, and through the clouds. But with the optical, we can see, we can extract, enrich the information. We have a spectral information, so we can be conclusive. This is another image. In the left one, we have but it seems to be oil, but we are not sure. We only have, because of the physical principles of detecting oil when using radar, it's because of the surface tension of the oil, so that there is a reduction of clutter. We have like a black spot of, it looks like oil, but we are not sure. Of course, this is something very close to the shore, and it's something to take into account. That this is the information we have with radar. On the right side, we have an oil spill in the same area, and in this case, we are conclusive. This is real mineral oil, and we can have more information. We know where is the thickest part of the oil, which is the hot spot where vessels needs to go to pick up the oil. So once we have this pollution in optical imagery, we have enriched information. So in a nutshell, the mission of orbital EOS is mainly to democratize the access to maritime intelligence. Yeah, this is why once Copernicus started to work, there are plenty of data. So we can access to a lot of information. And if we create good intelligence through this information, we can provide key insights. Taking all this into account, we have created EOS Viewer. In EOS Viewer, we try to gather radar imagery, optical imagery, all the expertise that we have gathered in the Spanish Coast Guard, and we truly believe that if we include an artificial intelligence engine, we can create a product really, really, really valuable for the industry. We are providing information, we are providing service for authorities and at this moment, oil and gas companies. Thanks to this project, we have been awarded the European Space Agency. We are very happy because for the ESA startup competition last year, we were awarded like one of the 3 top startups in Europe because of this project. So that it has given us it fostered our project. We are very happy. So this is just a brief imagery about how EOS Viewer works. It's just a SaaS platform, which is very interesting because it's we go under subscription. It's very easy. You only give one area of interest, and we start monitoring your area with radar technology. Of course, we extract in automatical way all this information. We can have the area. We use AIS data, so we can have information about the polluter. And as I was saying to you, if we use optical imagery, it's very interesting because we can provide where the thick oil is the red line. Blue line is the contour of the whole spill. Red line is the hot spot. And we can assess about the volume. This is about between 6 and 60 cubic meters. So this is a very good estimation about, okay, how we can manage this pollution. This is an oil rig in the north of Red Sea. So thanks to all of this technology, we can be much more cost effective than competitors because applying artificial intelligence, we reduce the number of experts working for giving information in a global scale. And we can be much more accurate because we have experts from the Spanish Coast Guard detecting and training our algorithms, of course. And just a few comments about the artificial intelligence. Yeah, it's in the end, artificial intelligence or machine learning is something about pattern recognition. This is extracted by the books and the philosophy of Edward de Bono, the guy who coined the term lateral thinking. And he said that, okay, the brain works by creating patterns and we repeat these patterns and use these patterns so that we achieve a knowledge. This is the way we think about we have to use artificial intelligence. If we create a lot of data, valuable data, we train this model, we will get a valuable output. Some experts say like, okay, garbage in, garbage out. If we train this model with not very valuable information, the result is not going to be good. One example of this kind of technology is, for example, algorithms for detecting skin cancer. If you are able to train a machine how a skin cancer look like in an image, and this is something that can be done by experts, by doctors. So if once you put in a model thousands of images of skin cancer, and what is not, of course, in the end, the machine will learn how this skin cancer, which is the pattern, which is the algorithm extract in a natural way the pattern. This is something that the doctor has done during the years. So in the end, the machine is going to learn. This is what we do. But instead of doing with skin cancer imagery, we do with oil spills at sea. This is a radar oil spill, and what we do is just pre-process. We cut it in a very small batches, so the model is able to learn from a small image. We use experts to create labels, and we train the model. So once we put this image, for example, in the model, in this image, only the two central black spots are a real oil spill. The rest is lookalikes, which is something that looks oil spill, but is created by part of shadows at sea. So our neural network will do something like that. So it's great. It has very high accurate. It still have some small mistakes, as you see there, but we are training with more and more data, and the data is improving. So we are very happy about that. This year we will start training models for optical sensors, and let's see. We hope to be so productive as in the one of the radar sensors. In orbital EOS, we have been requested to create some different applications regarding maritime domain. For example, SAMS, this is an algorithm to monitor how the shoreline is moving with the time. So if you do it in an automatical way, you can create trends about and just knowing if climate change is affecting the shoreline and how it's doing. This is a pilot we did for Global Omnium, and they are using it in their operational way. There are some other applications. For example, change detection is something that is very useful. There are many change detection algorithms that you can apply for emergency. For example, you can know if there are floods or some other changes. You can extract very valuable information. You can apply interferometry just to know if there are changes in dam. There are thousands of applications that come to my mind. That our main focus is soil pollution. And what about the future? What just telling the story? What we think? Which is in our roadmap? We are very excited because we are in three projects, long-term projects, to include the artificial intelligence on board. This is something that the PhilLab did last year with a satellite for detecting clouds. So we think that if we include our algorithms in a satellite, the satellite could only have the necessity to download information, not the huge images, so that it will be much more cheap and more easy to manage these satellites. So we truly believe that the future is to include the artificial intelligence in the satellites, and we are working with some companies for this purpose. Another necessity, another project, another importance that we need, mostly when we are dealing with emergencies, with real emergencies, is real time. That data, when dealing with emergencies, lose worth, lose value with when the time passes. So if we have an image 1 hour later, the spill occurs or the satellite pass, it's very valuable. If we have the image in 6 hours, it's less valuable. And if we have in 24 hours, there is no value at all. So this is something that we are pushing the European Space Agency and the provider of satellite imagery, that we need to improve this response time. And it's something that is improving with the time, but we still have a path to run. We need this information be accessible. If we want that Earth observation to be a commodity, something for to be used for everyone, for every company, for every people, we need to be accessible. There is no possibility of Earth observation to survive if you need a very complex algorithms, a very complex machinery to access. So it needs to be accessible, of course. And of course, as in the way we understand the Earth observation, is to create a wellness. Okay, this is one of the main value of orbital EOS. We provide solution to create a better environment, a better humankind, and of course, Earth observation for us is just a way to improve our staying in the planet. Yeah, of course. And that's all. Thanks for your attention. And if you have any question, I will pleasure.